Second kind of reaction is again a kind of substitution. If we take benzene diazonium salt, this is benzene, azo is for nitrogen, diazo is for dinitrogen, and em is the way of naming of positive charge, like oxygenium, hydrogenium. Here we have nitrosonium. So this is benzene nitrosonium salt or diazonium salt. Fine. I'm sorry, it will not be nitrosonium, it will be diazonium. Diazo is for 2 nitrogen and diazonium is a salt here. So this is benzene diazonium salt. On this salt, if we just add warm water, this benzene diazonium salt gets converted to phenol. Now this benzene diazonium salt is a very important intermediate that gives us lots of other functional groups directly. Now basically this is prepared from amine, and this benzene diazonium salt is prepared from aniline, this aromatic amine. We have a reagent, and that is sodium nitrite along with HCl. We keep the temperature very low. Now this reagent gives us this benzene diazonium salt. Now how this happens, basically this reaction we will study in great detail in the chapter of amines. Now I'm not dealing with the mechanism currently, but if you are very curious, you can type on YouTube benzene diazonium salt and you'll get a video corresponding to that and you can listen to that. But the proper time to deal with the mechanism is in the chapter amine. But for time being, this is what we get if we add this reagent in aniline. Now I will have an idea of what this is, and this in this diazonium salt what's happening is this N2 group is a very good, it's an excellent leaving group. Now this N2 gas will leave no matter what is left behind. If this N2 gas leaves, it will take away the electron of this pi bond and leave away, and the plus charge will come on benzene ring. And if you note, the plus charge is on sp hybridized carbon, and that is not a stable plus charge. But N2 gas is such a good leaving group that even this unstable cation is formed to facilitate the removal of N2 gas. That's why the temperature is very low. That's point number 1. Point number 2 is, when N2 gas is such a good leaving group and you're adding warm water, then that leaving group will go away and water will attack that plus charge. So that will result in phenol. So for time being, this will be sufficient for us to understand how we are getting phenol. But how we are getting diazonium salt out of aniline, that's the thing that we will be looking in the chapter amine, and I'll suggest you better have a look, because it will be a 10 minutes video. You better have a look on that video of diazonium salt. Look at the mechanism and you will understand how this aniline is being converted to diazonium salt. It's not a big deal, but still, I'm not dealing with it right now. So this aniline is giving us diazonium salt. That's good enough for us. And this diazonium salt, on addition of warm water, is giving us phenol, and that we can understand now. So that's how you can get phenol from diazonium salt. So let's solve a problem then based upon this small concept we have studied now. Suppose I have to convert benzene to phenol. Phenol meaning this compound. Then how am I going to do this? Now there are various ways of doing it, and one of the method via Grignard reagent we have studied before. So that's one way. For example, just to quickly remind you how we are going to do it with Grignard reagent. If you add Br2, AlBr3 or Cl2, AlCl3, whatever, you are going to get bromobenzene or chlorobenzene. If you make a Grignard reagent out of it, that means if you add Mg in presence of ether, you'll have a Grignard reagent. When we add oxygen and then we hydrolyze that peroxide that we are getting, then that results in phenol. This reaction we studied when we studied Grignard reagent. Fine, so this we know. We can prepare benzene, we can prepare phenol from benzene via formation of this Grignard reagent like this. So this is one of the pathway possible, and I hope you know this. In case you don't know, you go and see that lecture of Grignard reagent. Towards the end of that topic, we have studied this reaction. Now, this is one way of preparing phenol out of benzene. Another way would be using this reaction. So somehow try and think and prepare this benzene diazonium salt, and from here you know how to get phenol. So benzene diazonium salt is prepared from aniline, as we have just seen, and try to prepare aniline from this benzene. So aniline we haven't studied any reaction yet that brings NH2 group directly on benzene, but we have studied a reaction before that brings nitro group on this benzene. If we add nitrating mixture, then nitrating mixture consisting of 1:1 ratio of nitric acid and sulfuric acid brings a nitro group on benzene. That nitro group on reduction, when nitro group is reduced, we get amine group. This NO2 is reduced to NH2. Now from here you know what you have to do. You have to first prepare this benzene diazonium salt, and the reagent for that we have just seen a minute back is NaNO2HCl, keeping the temperature low. So this will give you benzene diazonium salt. And from benzene diazonium salt, if you add warm water, you are going to get this phenol. Fine. So this is how you are going to get phenol from benzene diazonium salt. So this is the second kind of method of preparation of phenol. Third reaction is an important one. We get it from cumene. Cumene is common name of isopropyl benzene. This is cumene. This isopropyl benzene is called cumene. What happens is this cumene on aerial oxidation gets converted to cumene peroxide. Oxygen is inserted between carbon and hydrogen. Now, in the chapter of hydrocarbon, when we studied this kind of reaction, that when you have a R group and you add KMNO4 to it, no matter what that R group is, you always get carboxylic acid, you always get benzoic acid. This is the oxidation reaction of alkyl benzene that we studied in the chapter of hydrocarbon. We also studied, if you haven't studied the chapter carboxylic acid yet, and the chapter comes after phenol basically. So in that chapter we'll also study this reaction, and this reaction will be a method of preparation of carboxylic acid. So in this reaction, in the chapter hydrocarbon, we studied, and let me quickly recapitulate you. If you have a R group, whether it's a hydrogen or suppose there's a carbon bond. Now what happens is when you are going for oxidizing this thing, now whatever the structure of R group is, this carbon is the one which is most electron rich, because the electronic density from the phenyl ring comes out and goes directly into the orbital of this carbon. Now other carbon which are attached to this carbon will have less electronic density because they are not directly attached to the phenyl ring. The carbon which is attached to the phenyl ring, that's most electron rich. When it comes to oxidation, so this is a site which is most favorable for oxidation, because oxidation is loss of electron. Leo Ger. Loss of electron is oxidation, gain of electron is reduction. So oxidizing agent is going to oxidize this, and oxidation will occur at this site because this is more electron rich. So loss of electron is more likely from here. So this is a carbon that is going to be oxidized, and when this carbon gets oxidized, it gets converted into carboxylic acid and the chain breaks from here. So rest of the parts are going to give you some acids depending upon their structure, but this part is always going to yield benzoic acid.